machine learning, artificial intelligence, neural networks, large language models, generative AI, and deep learning. What is the difference, and what is the relationship among all these? Let's look in this video. Let's start with artificial intelligence. Artificial intelligence is the broad concept that deals with developing machines, programs, or systems that think and act like humans. Machine learning is a subfield of AI where algorithms learn from data to make predictions or decisions. Rather than being hard-coded with specific rules, ML models improve through experience by being exposed to more data over time. Neural networks are the building blocks of many machine learning models. Inspired by how our brains process information, they consist of layers of simple processing units that work together to recognize patterns in data. Deep learning is a specialized form of machine learning that uses deep neural networks. Deep neural networks are neural networks with many layers, usually more than 3. It's particularly powerful in analyzing large amounts of unstructured data, like photos, audio, and language. Generative AI is a category of deep learning that doesn't just analyze data, but it creates data. These models can produce new text, images, music, and more by learning from vast amounts of existing data. Large language models are a type of generative AI designed specifically for language tasks. Built with deep learning techniques and trained on large-scale text data, they can generate coherent text, answer questions, translate languages, and even code. Think of them as the language engine behind tools like ChatGPT. Let's now look into each of these in more detail. Artificial intelligence is the science of developing machines that can perform tasks that typically require human intelligence, such as learning, reasoning, problem solving, and perception. Let's look at some common examples of artificial intelligence. Autonomous vehicles. Self-driving cars rely on AI to process sensor data, recognize objects, and make real-time driving decisions, mimicking the perception and actions of a human driver. Digital assistants. Smart digital assistants like Siri and Alexa use AI to understand voice commands, process natural language, and respond intelligently to user queries. Predictive maintenance in manufacturing. Artificial intelligence monitors equipment conditions in real time and predicts when maintenance is needed, reducing downtime and saving costs. Healthcare diagnostics. In healthcare, AI is used to interpret medical images, detect anomalies, and assist doctors in diagnosing diseases faster and more accurately. Facial recognition for security. AI identifies individuals by analyzing facial features, enhancing security in airports, smartphones, and surveillance systems. Fraud detection in banking. AI systems analyze transaction patterns to detect suspicious activities, helping banks prevent fraud before it happens. Algorithmic trading in finance. In finance, AI executes trades at high speed by analyzing market data and predicting price movements in milliseconds. Customer service chatbots. AI-powered chatbots provide instant 24/7 customer support, handling everything from order tracking to answering FAQs. Recommendation systems. Platforms like Netflix and Amazon use AI to suggest shows or products based on your past behavior, increasing engagement and satisfaction. Let's next look at machine learning. Machine learning is a subset of artificial intelligence that allows systems to learn from data and make decisions or predictions without being explicitly programmed. Instead of using fixed rules, ML models identify patterns in data and use those patterns to improve performance over time. Machine learning powers many AI applications you interact with daily, from spam filters to personalized recommendations. The first step in the machine learning process is to select the right machine learning algorithms for our task. Different tasks require different models. For example, if the output of a task is to predict values, then we will choose algorithms such as linear regression or logistic regression. If the output of our task is classification, then we will choose algorithms such as decision trees and random forests. The next step is to collect relevant data that will be used as input or training data to the ML algorithm that we chose in the first step. This data could be text data such as customer reviews. This could be images such as medical images. This data could be audio files for voice recognition, or they could be video files. Once this training data is collected, we have to pre-process this data. Raw data often contains noise, duplicates, or missing values. So it's cleaned, deduplicated, and normalized before use. So after pre-processing, we have a subset of data that is ready to use as training data. The next step is training. In this step, we send the pre-processed data to the ML algorithms. The output of this step is the trained ML model that can be fed real data, and it will perform the required task such as prediction or classification. After training, there are additional steps to validate and test the model on unseen data to ensure it performs well in real-world scenarios, and not just on training data. Once the model is trained, validated, and tested, it is ready to accept our real-world data. Here are some real-world examples. We send a product user review to the model. The model outputs the sentiment behind the review as either positive or negative. This type of ML output, where the result is binary like positive or negative, spam or not spam, fraud or not fraud, etc., is termed as classification. Another example is with home sales. Given a home with features like square footage and location, the model predicts the likely sale price. This type of ML output, where the result is a predicted number like temperature, sales number, income, etc., is termed as regression. Another example is grouping of shoppers based on how much they spend. Given a shopper, the model groups the shopper as a big spender, medium spender, or a budget spender. This type of ML output, where the result is bucketed into groups, is termed as clustering. Next, let's move on to neural networks, which is a subset of machine learning. Neural networks is a key technology behind many machine learning systems. Inspired by the structure of the human brain, they are composed of layers of interconnected nodes called neurons that process and transmit information. These networks learn to identify patterns and relationships in data, enabling them to power applications like image recognition, language translation, and more. The first layer of a neural network is the input layer. This is where the network receives data, like a photo or sentence. Each piece of data is turned into numbers that the model can understand. The last layer is the output layer. This layer produces the final result, whether it's a classification like a cat or dog, or a number like a price prediction. In between these two layers, there are one or more hidden layers. These are the processing zones. The input gets transformed step by layers of neurons that learn more complex features at each level. So in this example, the data is processed by the input layer and sent to the first hidden layer. The first hidden layer further processes the data and sends it to the second hidden layer. The second hidden layer processes the data and sends it to the output layer. The output layer does the final processing and provides the final output, which could be, for example, classifying an image as a cat or dog. Weights are added to each of these processing nodes. After the model makes a prediction, it checks how wrong it was and adjusts its internal weights to improve next time. This is called back propagation. The nodes also contain and use activation functions. These functions determine whether a node or neuron should fire. This enables the network to capture non-linear patterns in the data. Let's now look at some real-world applications of neural networks. Image recognition. Neural networks power face detection and photo tagging by learning to recognize patterns like shapes and edges. Voice assistants. These networks convert spoken language into written words and interpret intent, allowing devices to respond accurately. Medical diagnosis. In healthcare, they analyze images like X-rays or MRIs to identify diseases, sometimes even outperforming human experts. Language translation. By understanding grammar and context, neural networks enable accurate, near real-time translations across languages. Financial forecasting. Neural networks detect trends and anomalies in stock or sales data to help forecast future values. Next, we will look at deep learning. But before that, if you are finding this video helpful, please give it a like and share it with someone who might enjoy it too. And don't forget to subscribe to the channel so you can join us on this AI learning journey and get notified whenever we drop new content. Let's next look at deep learning. Deep learning is a subset of machine learning that uses complex neural networks with many layers, hence the term deep. These models can automatically discover intricate patterns in large unstructured datasets like images, audio, and natural language. Deep learning powers many of today's most advanced AI systems, such as voice assistants, facial recognition, and autonomous vehicles. So let's depict our deep learning model. It is basically a neural network with more than 3 layers. In this example, we have the input layer, 3 or more hidden layers, and the output layer. Generally, any neural network with more than 3 layers is a deep learning network. But in the real world, deep learning models are made up of dozens or even hundreds of layers, each learning progressively more abstract features. The training data that is fed to deep learning models can be any digital data: text, images, audio, or video. Deep learning models are data hungry. These models need large data sets to perform well. We are talking about millions of images, hours of audio, or pages of text. This data fed to deep learning models is unstructured data. Traditional machine learning struggles with raw text or images, but deep learning handles them with ease. Another aspect that deep learning excels in is automatic feature learning. Unlike traditional machine learning, where you manually select which features matter, deep learning figures that out on its own. Deep learning scales with resources. The more data and computing power you give a deep learning model, the better it tends to perform. Let's look at some real-world examples of deep learning. Self-driving cars. Deep learning helps vehicles identify objects in real time, like lane markings, stop signs, and people. Voice recognition. It powers the ability of smartphones and assistants to understand your voice and respond accurately. Facial recognition. Deep models analyze facial features to identify or verify individuals quickly and securely. Language generation. Tools like ChatGPT use deep learning to generate human-like language responses to user input. Medical imaging. Deep learning can analyze thousands of medical scans and highlight potential health issues automatically. Let's next look at generative AI. Generative AI is a branch of artificial intelligence focused on creating new content, such as text, images, music, and code, based on patterns it has learned from existing data. These systems don't just analyze information, they generate something entirely new. Generative AI models are built using deep learning and have become popular tools for creativity, automation, and productivity. The generative AI models are deep learning models. Most generative AI uses deep learning techniques like transformers for text and generative adversarial network for images and video. The training data that is fed to generative AI models can be any digital data: text, images, audio, or video. These models are trained on huge volumes of data, millions of images, books, or audio clips to understand style and structure. Generative AI is different from the other AI categories we have looked so far. Once trained, the generative AI model can generate content that is similar but not identical to its training data. This makes the output original and useful. It can generate not only text, but also images, sounds, videos, and even 3D designs. The output generated is tailored based on a user input. The user input is commonly called as natural language prompts. Let's look at some real-world examples of generative AI. Generative AI tools like ChatGPT and Gemini can write blog posts, product descriptions, or help draft emails in seconds. Generative AI tools like Midjourney and Stable Diffusion can turn a text prompt into original artwork, designs, or illustrations. Generative AI tools like Iva can create new melodies and rhythms in various genres used in ads, games, or personal projects. Generative AI tools like Synthesis and Runway can produce short videos from scripts or generate avatars that mimic human presenters. Let's next look at large language models. Large language models are a type of generative AI trained to understand, generate, and interact using human language. They are built using deep learning techniques and trained on massive data sets, often including books, articles, websites, and conversations. Large language models can perform a wide range of language-based tasks, such as answering questions, summarizing text, writing content, translating languages, and even coding. The large language models used are deep learning models, which use deep learning techniques like transformers for text. Examples of large language models are OpenAI's GPT series and Google's PayLM. The training data that is fed to large language models is text data such as books, journals, scientific publications, websites, forums, articles, etc. These models are trained on huge volumes of data, millions of books, publications, articles, forums, and more. And these models operate with billions of parameters, which are the weights and connections that are adjusted during training. The size allows them to store vast knowledge. The large language models can grasp the context and nuances of language, such as sarcasm, tone, or subject switching. With just a few words or a question in the form of natural language prompt, large language models can generate coherent, contextually appropriate paragraphs or responses. Let's look at some examples of these large language models. Large language models write detailed stories, articles, product descriptions, or marketing materials in seconds. Large language models provide conversational support for users, answering questions, or holding meaningful dialogue. Large language models help programmers by writing code, finding bugs, or suggesting improvements. Large language can understand and translate text across languages with surprisingly high accuracy and context awareness. Thanks for watching. For more in-depth content like this, visit us at interviewgrid.com. If you found this video helpful, go ahead and give it a like and share it with someone who might enjoy it too. And don't forget to subscribe to the channel so you can join us on this AI learning journey and get notified whenever we drop new content.